Okay, well, this one looks quite nice because it's already got one equation that's eliminated the x. This second equation has no x's in it. So in other words, I've already got y plus 3z equals 6. So I'm going to use equations 1 and 3 to eliminate the x's in this. And what I'll do is I'm going to multiply this first one by negative 1, okay, to give me a negative x. Okay, I'm going to bring it down here. So multiply by negative 1, that'll give me negative 1x to go with the positive 1x, if you see here. Multiplied, that's going to be positive y, and negative 1 by with 5, that's 5z. Okay, and that equals 3. Okay, add these together. Let's have a look. So the x's will go, so I have 2y. Plus, what's that? That's 1z and 5z. 6z equals, that's 12. Is that right? 12. Okay. Okay, so I'm going to put that over here with this one. So 2y plus 6z equals 12. So what I'll do is I think I'll eliminate the y's. I'm going to multiply this one by negative 2. Okay, by negative 2. And I will get negative 2y negative 6z, so remember this is now this down here, equals negative 12. Now look what's going to happen here. Gone. Ah, now this is not like the other one. That left me 0, I think it was equal 77, which made no sense. That's why it's no solution. Now 0 does equal 0. That's fine. Okay, so this isn't going to be no solution. This is one of those that's actually an infinite amount of solutions. Okay. Okay, so when we have the infinite amount of solutions problem, how do we actually write the answer? We've already seen that we could have no solution. We've seen the problems where we get x, y, and z, answers to that. But how about in this infinite amount of solutions? Well, here's what we do. Okay, so let's just start with saying this. Okay, so we'll let z equal, well, the letter z. Okay, so if z is z, of course that makes sense. What does y equal? Let's have a look here. What does y equal from here? Well, y equals, if I take away 3z from both sides, I'll get negative 3z plus 6. Okay? So, how about, what does x equal? Right, okay, so I'm going to put y into this first one. Remember, y is negative 3z plus 6. So let's just do this. Okay? So x minus y, so minus negative 3z plus 6 minus 5z equals negative 3. Okay, so again, I'll just go through it again. I'm letting the z equal the letter z, kind of makes sense. From this one, I found out what y equals just by taking away the 3z. That's all I got that. And then once I know that z is z and y is negative 3z plus 6, can you see that basically everything's in terms of the letter z? Then here we go. Let's have a look at this down here. So x. Just think about distributing a negative 1 through this. Be careful of this. This can be tricky. Plus 3z minus 6 minus 5z equals negative 3. So I'm going to take away 3z from both sides. I'm going to add a 5z. I could combine those right now. Add a 6 to get at what x equals. So if 3z take away 5z, well, that's negative 2z. If I have negative 2z to both sides, I'll get positive 2z on the right. If I add a 6 to both sides, what's add a 6 to? A negative 3. I'll get positive 3. So again, I got rid of that, that, and that. You know, basically just threw them onto the left, the right-hand side. So there we go. So here's how you write the solution. Okay, here's how you write the solution. Okay, x, y, and z. X is 2z plus 3. Y is negative 3z plus 6. And z is z. So believe it or not, that is how you write the answer. Just like supposing the answer, I can remember way back, what was the problem originally when I had x was 3. I think y was -1, and I think z was 2. Okay, so that would be how I'd write the answer if I got the solutions in terms of the integers. Okay, and of course also there's no solution. So again, there's your classic, we get an answer, here's your no solution, here's your infinite amount of solutions. So really, with the infinite amount of solutions and no solution, you can actually get to realizing what's what pretty quickly. You don't have to solve all the way through. It's just the infinite amount of solutions one just takes a little bit of, how do you write the answer? Okay.